area which I think is neglected sometimes, even internationally. Cyber security, sometimes people take it lightly and end up in trouble. So great to see in our Calicut one of the best academies being set up. So congrats. Thank you. So coming to machine learning and myself, like Misha told, I took a railway train to machine learning. This is how I reached. My road was a train track because this is the app, like he mentioned, released in 2011. I have actually some experience coding from school days. I used to do some web design, JavaScript, and then picked up some Java while I was in MBBS. And later, many years later, when I learned about Android, was using Java. Then I brought a book, and I was traveling a lot by train. So that's how I got this idea. This was my first project in mobile app. I learned Android actually because I wanted to make this app. Now it's got around 26 million downloads, 2.5 million monthly average users. It has been featured the highest. It has reached number 9 in the Play Store overall 2016. It's now in the Made in India app mentoring program, and there's been taken as a case study by Admo. And I was invited in the app conference in Singapore 2016. Just briefly about the app. Now the app has, over years, I have a partner now. He is Mr. Indra Kumar. He is in Madurai. He is also come from a typical route. He is a pharma person who is a PhD coder, and we met up accidentally, and now he is helping me maintain both the Android and the backend. And we have voice search, things like if you search Calicut to Chennai, like Chennai there will be some 8 different stations, so you have to select the best one. So this kind of matching voice search is in there since some time. We have a live train map which calculates train status from device data and location. And now we have PNR status prediction. Currently, this is the only app which you can find both RAC and confirmation chances. All the other apps only give a confirmation chance, but we are able to give a split chance because we used machine learning. So basically, I think Hemant also touched upon this. We need a lot of data to train, and we were collecting this because we knew that this was missing from our app. It was there in many other apps. So we needed to start collecting PNR confirmation data to understand how a ticket gets confirmed. We need a lot of data to study about that. So once we had around some millions of examples, I decided we will do only machine learning instead of actually going through an algorithmic approach. So you can actually do it algorithmically. You can do it through looking at the database and historical percentage of prediction given certain parameters. You can do it in code. Instead of that, we tried to took it as a challenge to learn machine learning. So how to start? And TensorFlow was the popular framework which was getting a lot of press. So I vaguely decided that we will do it somehow using TensorFlow. So data is the fuel for machine learning. So this is just a general tip. Anybody doing data, machine learning, planning to take up in projects, if you don't have enough data, you have to get it from others. There are a lot of public data sets available for training and research. If you search, you will find them. So you can use that as to robust to increase your training examples. So how I got started, because I was already having the app running, but machine learning was a new field. This was last year. So I enrolled on this course for a machine learning course by Stanford University. It's available in the site Coursera. So this is how I understood the other. Till then it was just a term for me, machine learning. What is actually machine learning? From ABC, it's this Professor Andrew NG's course. This is how I started this field. I proceeded to the next course in that deep learning, and did also some practical machine learning course in Google Cloud. All this is available in the same Coursera. This is a good place to start with. And the TensorFlow website, they give a lot of examples. Once you know what machine learning is, you can really go through these examples, and doing it by hand gives a lot of confidence. And even the Google Cloud machine learning is, if you type that, Google has a lot of cloud machine learning examples, which is their part of their Google Cloud offering, but they give a lot of samples, so you can study them. Examples are very simple ones like predicting housing prices from census data, things like that. These are basic machine learning examples, like the linear regression examples. And of course, there is a free course now available called Machine Learning Crash Course. It is a little bit accessibility is not there. If you don't know machine learning, it's very difficult to understand this course because it really is very fast. They don't really take you through the basics. That's one problem. But it's freely available, and they say that they use it internally for training in Google. So this is now just if you type this, it comes. It goes step by step and all. So it's one thing worth looking at. Machine learning crash course. Now, when I talk about machine learning, many people, or especially when I talk to non-IT people, they think that it's all about images, artificial intelligence, human-like language recognition, all these things. But what about databases? It's very boring, structured data. But if you look at it in practice, even in Google, 60% of the machine learning is operating on structured databases, including like cyber security. You'll be looking at file characteristic, which is in a table. So table of data is a good place to start machine learning. Type of network is fully connected network, which we call or MLP, multi-layer perceptron. This is the most fundamental type of neural network available. Now, if you have sequence data like speech recognition or language processing, you use sequence models, and if you have images, you use convolutional neural networks, but they come to a much less percentage. Like convolutional networks come to only 5% of the deployed models in Google, as per the published data 2017. So don't miss structured data when you are studying machine learning. That's the foundation. So coming to some basic thoughts about machine learning. This is how you frame a machine learning problem. You need to be clear what is being predicted. In our case, it was ticket confirmation chances. What data is needed to find that prediction. So this final status of a ticket, not confirmed, RAC confirmed. It's a multi-class classification. It's not just two. If it's like confirmed, not confirmed, it becomes a binary classification. Once it's more than two, it becomes a multi-class classification. So what is the so-called activation function which gives multi-class output? Can anybody tell me that? Everybody familiar with neural networks? Yeah, it's not, I'm just talking about the mathematical function. It's called softmax. It's an exponential function which takes the output of the neural networks and converts it into probabilities. Softmax function. This is what we use as the final layer in a neural network when you need multi-class. For example, you want to classify digits 1 to 10. There's a MNST database which is commonly used for learning machine learning. It is handwritten digits 0 to 1. 1 to 9. 0 to 9. So 10 different digits are there. So you want to classify which one from the image, and it will be 10 classes. So then you use the softmax function. If you want to classify into two, like for example, you have a lot of images, you want to classify image of cat versus not cat, binary classification. Then you use what is called a sigmoid activation. This is an extension of that, softmax. What is the data we require? We require previous confirmation data, a lot of data, historic PNR data there. There are some slides which I think are a little random. These are more advanced, mainly for people who use TensorFlow, and some things which I picked up while actually implementing the neural network. In TensorFlow, they use this function a little differently from other libraries. It is used where the loss is calculated before the softmax. This is called logits. That's the final layer of the neural network. But the softmax result is useful for it. It gives a probability, and this is what we are actually showing in the as a ticket confirmation percentage. So that's what they reached. So basically, we need to create a data set for training. We need to build a model, and the last step is actually putting that model in a way it gives value to the user, operationalize the model. So coming to feature selection. We have a lot of data from the uh, historical records, like the file, we have a lot of parameters. Maybe all of them are not really important. So you need to use some human insight there. Everything cannot be done by machine. So these are the things which you look at when you select a feature. It has to be related to the outcome. So you cannot tell the train name, number of characters in the train name may not be related. But if you train number may be important because each train is different. So it has to be some way, some logic has to be there for each feature. It has to be numerical. You cannot use a non-numeric attribute. It has to be available at prediction time. This is a trap because sometimes you cannot use something which is not available. Sometimes you have a lot of data in your database, but many of these will be coming only after the confirmation. So you cannot use something which is not available. And you should have enough examples. And this is what is called validated by human insight. So this is like looking afresh at what we normally take for granted. So you really need to understand data. Anybody studying big data will know about looking at data and putting human insight to extract proper features from data. So these are the features which we selected finally. The ticket booking status, the train ID, the from station to station, day of journey, day of the week, days to journey, the class like the AC, sleeper, first class, something like that, the quota, which is the general quota or the remote location quota, different quotas are there. All this is provided in the ticket, in the PNR status. Another insight which I, again, practically when I started implementing time. When you have time as an input in a machine learning model, you never use it raw. You have to actually parameterize it. You should like either convert it into things like day of the week, day of the month, day of the year, hour of the day, etc. Depending on the level of granularity required. For PNR, you may not need hour of the day, but we use day of the week because each weekday may be different. Monday may be different from Sunday. Day of the month may be important. Day of the year may be. So depending on, again, use your insight to select time appropriately. Don't just use the raw time stamp or second since 1917. That type of number may not actually help in training. So ingestion is feeding data into the neural network. We had data in MySQL database which was exported to CSV files and pandas for transformation, like we just saw in the Jupyter notebook. There are online tools available to do this in large scale, like Apache Beam, which we have not used. Cloud Data Flow is another example of transforming huge amounts of data for training. Now coming to the actual training. If you look at TensorFlow, it is an execution engine is there. And on top of that, you have low-level APIs in C, in Python. On top of that, you have further higher level things like layers, datasets, and all. At the highest level, you have what is called estimators. Estimators are a very simplified way of looking at machine learning because you just have to plug in everything and it runs by itself. You don't have to really look into the nuts and bolts of making a neural network. So the benefits are it's easy to set up, train. You can create different type of data, like categorical data, for example, how it's just a category. That kind of data, how will you feed, or example stations, Calicut, Toronto, how do you feed that into a neural network? So it is called feature columns. I think all libraries provide this, TensorFlow also provides. And the most important thing which we have found is that it is easy to export it for deployment. Once you need to run it at production scale, where you need the response within milliseconds from the model, it becomes an issue, and this provides a lot of ways to do that. And it is customizable to whatever extent you want. You can do a fully custom model also, you can do that. And again, some tips. Categorical features. You cannot feed a categorical thing like a train station name to a neural network. It accepts only numbers. So for example, you have 1200 trains or stations. These are called sparse columns because each column will be for one train. And it will be one if the train is the one, or it will be zero. So you have so many columns, 1200 columns, most of it will be zero. This again is not very efficient because the zero, as you know, if you input it, it will multiply and cancel it out. So the training will be very slow and you cannot train using this kind of data. So what we do is a technique called embedding, where we bring it down to maybe around 10 columns. using a simple layer. We just multiply it with parameters and add it into 10 layers. So that's called embedding. It's a very simple mathematical operation. It gives a lot of power to the network. It reduces extensively things like language, natural language processing. If you use anything like Google Assistant or Google Home, when you speak, it immediately picks up the sentence structure. What is the verb? What is the noun? Everything is done using embeddings. So this is an embedding layer. This is from another example. You have a sparse encoding with a lot of values. You just decrease it into a smaller number of nodes. It's called embedding. Then this embedding is then fed into a neural network, so that it becomes very easy to manage and gives a lot of additional benefits of the embedding. So this is some code example. This is how you make an embedding column. Previously I had shown making categorical column. This is how you make a categorical column with the keys, train number, and 1200 different train numbers. This is just telling it how to read this particular data from the CSV file. This is the heading, train number. This is the number of different entries, and this is the data. It's an integer value. And then you put that inside an embedding column with 10 dimensions. Everything else is taken care of by the engine. Then it's time to make a neural network using this. So neural network is made using a single command, deep neural network classifier. Feature columns are the input columns which we defined. The number of neurons, you can just put it in a list with the separate by comma. You need to have some idea why each layer. Generally neural networks are designed so that it tapers down. The first layer will have maximum number of neurons, and the output it comes down. And there is a lot of discussion on which is the best way to design neural network and all that. So generally this is what is followed. And the number of layers in the first input is same as the number of inputs. So because we are using 69 different inputs, it came as 69. This is a directory to save the trained model, and the number of output classes, which is 3, which is confirm, RAC not confirm, 0, 1 and 2. So with this code we actually made the neural network. Next line, this is Python code. Next line is to train the network. We use the CSV file as an input, and the batch size is a parameter which is passed to it, and the steps, number of steps to train it. So this is almost taken directly from this example in the Google Cloud for census data. This is the link, so you can see that it's very straightforward when you understand what's happening. It's just designing the network and training it on the input data. How to process the data, everything is defined in the feature columns. So once we trained it, it was running fine. We needed to deploy it in the app. But when you actually run TensorFlow, it's very heavy. It takes around 3 or 4 seconds to start up, and you cannot use it in a web service. We needed a response in milliseconds. So then the practical issue how to serve machine learning into a API, web API came up. Then they provide this service called TensorFlow Serving, which is also part of the TensorFlow package. But this took some time to understand how it works. It's converting a machine learning model into an API. The steps are to export what is called as a serving model, and then you load it into a model server. Initially they supported only a proprietary thing called gRPC, but now it provides a REST API. Production. The entire details are given in the serving section of the TensorFlow website.